Hello, and thank you so much for tuning in today. My name is Alexander Fedchin, and I will present on behalf of my co-authors, Alexander Chakarov, Zvonimir Rakamarić, and Rungta, the work that we did on extracting better counterexamples in Dafny programming language. Dafny is a verification-aware language that allows the developer to write specifications for a method using preconditions, postconditions, loop invariants, or assertions, like in the program you can see on your screen right now. No need to figure out what this program does. I will return to this example later. What is important right now is that Dafny can verify that the implementation of the method satisfies that method's specification. And of course, this is not always the case. Dafny would sometimes fail to verify a program, which can happen either due to Dafny's incompleteness or to a bug in specification or a bug in the implementation. Indeed, the program that you can see right now, Dafny cannot verify because there is a bug. And in situations like this, you would want Dafny to explain to you why a particular proof fails, to show a counterexample that shows why some assertion does not hold. But unfortunately, so far, Dafny has lacked in such debugging functionality. I'm currently working with an older version of Dafny using an extension in Visual Studio Code IDE. And so if I query this older version of Dafny for a counterexample, it would give me this incomprehensible output that does not explain why this program, why Dafny cannot verify this program. You can see that the only information it can extract concerns integers and booleans. But it can't do anything with more complex types. So our work lies in improving upon this earlier version of Dafny in terms of the counterexample extraction functionality. To show why counterexample extraction is such a difficult task, let me walk you through the process, the steps that Dafny takes to verify a program. On your top left, you can see a very simple program that Dafny would fail to verify. The reason being that there is an assertion that states that the argument to the method is not equal to literal C, but then there is no precondition that would mandate that the argument cannot be equal to literal C. So this assertion fails. But in order to come to this conclusion that Dafny fails to verify this program, it first needs to translate it to an equivalent Boogie program. Boogie is a lower level language that also supports verification. And you can see additional instructions whose purpose might not be clear. They're there to support some features that Dafny has and Boogie doesn't. But you can still see this assertion at the bottom of the method that states that the argument C is not equal to a character corresponding to the ASCII code 99. Now Boogie, in turn, translates this program to a query to the underlying theorem prover, usually Z3. And Z3, if it fails to verify the query, it provides something called counterexample model. These models are usually hundreds or thousands lines long. What you can see at your bottom left is an excerpt from such a model that is sufficient to explain why Dafny fails to verify this small program. So you can see here that variable C is associated with some ID 67. You can then see that the type of a variable with ID 67 has ID 14, and that the type with ID 14 is character type, so this variable has type character, and then you can use this character to int map to see that this character has ASCII code 99. And so from this you can extract this information that this counterexample that shows that if the argument to the method test is equal to literal C, this assertion fails. Now, of course, this is a very simple example, and even with this example, it can be daunting to look at this Z3 counterexample model, which again is actually hundreds of lines long. You have to look for these specific lines in it. But we support counterexample extraction not only for characters, but for many other types as well. Our contribution is adding to Dafny the functionality that allows extracting counterexamples in all of their complexity, with support for all primitive types, but also more difficult cases, such as all commonly used collections, class types, algebraic data types, arrays, and nested counterexamples. Here on this slide, you can see examples for all of these types that I just mentioned. In the second column, you can see assertions over variables of these different types. And then in the third column, you can see a counterexample that our model generates for these assertions. All of these assertions fail because they are introduced in absence of any preconditions. Now, this functionality has been available in Dafny since version 3.3, so we invite you to try it out for yourself using the Visual Studio Code IDE and the Dafny extension. So the rest of this presentation will largely be a demonstration of how counterexample extraction works in the context of the Visual Studio Code IDE. But we invite the audience to read the paper for details on how we extract counterexamples for variables of various types. So here on your screen right now, you can see the initial example that we started with. And in Visual Studio Code, if you have the Dafny extension installed, you can click on Show Counterexample and you will see the counterexample that we discussed before. Here is perhaps a more interesting example with an assertion over a sequence of integers. And you can see that this assertion fails if the input sequence has at least 2 elements and if its second element is equal to 3. And this is indeed what the extracted counterexample tells us. Note that the counterexample does not say anything about the first element of the sequence because it is irrelevant to the assertion failure. This is of course a feature of how the prover works, but it is reflected in the counterexample that we extract as well. Here is a more complex example that involves some object-oriented programming. You can see that there is class pattern with a single string instance field p and a method match that allows to match an arbitrary string against the pattern. And the string is set to match the pattern if for any character in the string the pattern has the same character or the question mark character. And so right now you can see that the implementation of the method satisfies the specification of the method, so Dafny successfully verifies this program as the plugin tells us. But if you remove this condition here, you will essentially turn this method from a matching method to a string quality check in terms of its implementation, while its specification stays the same, and so you have a discrepancy, and now Dafny fails to verify this program. So you can query Dafny for a counterexample, and this is a counterexample that our tool provides. And you can see that S is said to be a sequence of character or a string, which is equivalent to Dafny, that has A in it. And then the receiver, this, has type pattern, as you would expect, and it has a single field P, which is assigned some ID at2. Then at2 is itself a sequence of characters or a string, which is equivalent. And then you can see that that string has a question mark at the same position that the input string S has letter A. So the two strings are not identical, and they but they do match according to our definition of matching. Because of this, you get this discrepancy between the implementation, which says that the two strings are not equal, so return false, and the specification, which says that this string S should match this pattern P, and so the method should return true. And for our purposes, what is important is that the counterexample instruction can be recursive. So you can see that we first extract the value of the receiver, this counterexample, but then this receiver has a field, and so we recursively extract the value of the field relevant to this counterexample. To recap, we have developed a tool that provides Dafny programmers with human-readable counterexamples extracted from low-level information that is provided by the underlying theorem prover. Our tool works with all commonly used Dafny types, and it can be employed in the context of the Visual Studio Code IDE. In the future, we plan to use counterexample extraction for test generation, because a counterexample extraction allows us to query Dafny for inputs to a method that trigger a particular basic block or path to be visited. We also envision that more work can be done on improving integration with Visual Studio Code. In particular, more can be done on displaying longer counterexamples, as they're currently being displayed on one line. And there are also some rarely used Dafny collections, such as infinite maps or infinite sets, that we do not currently support, but could add support in the future. We would like to thank everyone who has reviewed our pull request to Dafny and Boogie and has provided feedback on both the text of the paper and on the usability of the tool. Thank you.